Okay, over to you, John.
There we go. Okay, hello folks, whether live or watching on video. My name's John Skeet. I'm a C# developer working for Google primarily on the Google Cloud Client libraries, but also, as we'll be talking about today, on the functions framework. You may know me from Stack Overflow or C# in depth. I'm sure my publisher Manning would love me to just mention briefly, I have another book that I've been working on with Tomasz Lalak called Software Mistakes and Trade-offs. Go find my blog and you'll find links to it. I have, speaking of links, I've got on the screen now a bunch of links related to today when we're talking about Google Cloud Functions and the functions framework for .NET. I mentioned before, but please do interrupt with questions. I'm sure if you have a question, then everyone else will want to know about it as well. Now, these days, most people kind of know what functions are. You may be used to AWS Lambda or Azure Functions. I have used Azure Functions. I have not used AWS Lambda. I haven't used AWS at all, frankly. I can't do a good comparison between the three, partly not having used AWS Lambda, and partly my experience of Azure Functions is pretty much like, I will just try it. Does it work? Yes. Oh, there's the emulator, and troubleshooting when people have found issues using the Google Cloud libraries from within Azure Functions, particularly in version 1, where assembly binding redirects didn't always work and things. So I don't know much about those ones, but I do know pretty much everything there is to know about the functions framework for .NET. And just to separate out two things, there's Google Cloud Functions, which is a specific serverless platform that you can deploy source code to, and it will run your function for you, etc. And then there's the functions framework, which is a very lightweight, in terms of there isn't very much code really, library / platform / SDK, whatever you want to call it, to basically just host your function so that you have to write very, very little code yourself. There's almost nothing that completely binds the functions framework to Google Cloud Functions. It does have built-in support for converting some legacy event formats from Google Cloud Functions into Cloud Events, which we may just about get time to get onto, but we may not. However, there's nothing to stop you from running the functions framework on Azure or AWS or wherever you want to run it. I have no idea whether you could easily hook up an Azure function to talk to the functions framework, but you can certainly run it locally, which is what we'll do to start with. So I designed the functions framework for .NET following a pattern that other languages have been asked to follow, the functions framework contract, so to speak, on the grounds that if everyone follows the same pattern of I will obey these environment variables, then the way that Google Cloud Functions works can sort of rely on that functions framework. However, the .NET specific aspects are entirely up to me. So we'll start from the command line, and we will start with a Hello Chicago directory. So I've just created the directory, gone into it. Hopefully you can all see the console, by the way. Shout if it's not big enough. And we're going to install to the minimal extent that we need to the functions framework. And in fact, you don't have to do this, but it makes things easier. What we're going to do is install the functions framework templates. So if I do .NET new -i to install some templates and Google Cloud Functions.templates, and then that will just take a little while. It used to be that you had to specify the version, but as of about a week ago, the functions framework is GA, so as in it's hit 1.0, and you can see hopefully that it's listed 3 new templates. So we're going to start off with GCF HTTP. So this is going to create a function that just gets invoked by an HTTP trigger. If you're used to Azure Functions, you're probably used to a huge range of triggers. There aren't many triggers in Google Cloud Functions at the moment, But as one of them is cloud events, and Google is sort of betting big on cloud events with its EventArc product, the idea is everything will be triggered with cloud events, other than just straight HTTP requests. So GCF HTTP is the simplest one, and we'll just do .NET new GCF HTTP, and it's created some files for us. It's created 2 files, and they're both really simple. So we've got the only C# file basically creates a class called function with a single method in it. And I'm just going to briefly edit that just so that it's Chicago specific, so that hopefully you will trust me that it really is deploying. I'm not going to bother building it just now. I will do so in a second, but we're just going to deploy it. So one thing I have done before starting all of this is install the gcloud SDK and logged in, etc. And I'm just going to do gcloud functions deploy, and we'll call this Hello Chicago. We need to tell it to use the .NET 3, as in .NET Core 3.1 runtime. Currently, that's the only .NET runtime there is. We will be looking to do .NET 6. We're skipping .NET 5 because that's not a long-term support release, and we want to only release things with long-term support. We need to specify that it's trigger HTTP. I'm hoping over time we may need less of this, and it may just get simpler. I won't bother saying that we can allow unauthenticated. It'll prompt us for that. We need to say the entry point is hello Chicago .function. And again, I want to be able to get rid of that. So that's all we'll need, I think. Okay, and yes, we will allow unauthenticated invocations. Right, it is now deploying. So what it's done at this point is it shipped up the source code and the project file up to cloud build, and it's going to build that and then deploy the function and tell us the URL for the function. While all that is happening, I will run it locally. So I showed you the function C# code. If I show you the CSproj file, it's literally just a package reference to Cloud Functions hosting. And if you've got any app settings.json files, then copy those as well. So you may be surprised that this works, but it will. If I do .NET run, it will build it, and we're running. And if you've ever used ASP.NET Core, which I suspect most of you have, this will not look particularly surprising to you at all. This is ASP.NET Core. I have slightly modified the console logging so that it gets log entries on a single line, but apart from that, it's all just normal. And if I go to my browser and run it, so this is running locally, and Hello Chicago comes up, and we'll see that, yes, we got appropriate logs with scopes and everything. Now, by now, oh, it's still deploying at the moment. It shouldn't take much longer. But you've seen that we can run it locally. You can also run specifying an entry point. So if we specify hello Chicago bad function, it will try to run it and say, oh, that function doesn't exist, can't load specified function type. You can specify the port and a few things. But for the most part, if your project only consists of a single function, .NET Run is your friend. It works in the debugger. It's all, it's very simple. None of this code is desperately clever. I have taken one really nice idea from the Project Dragonfruit project. And we now have the deployed function, and I'll explain what that clever idea is from Project Dragonfruit in a minute. But other than that, it's just kind of normal ASP.NET Core with a few useful things built in. And we'll see that now we're live with a function. And if I go to the Cloud Functions console and just refresh that, I could have hit the refresh button instead. We will see that we've got Hello Chicago as a function there, and I can go through to that and see. So we're not seeing many many invocations yet. It comes in a few, in a minute or two. We can see the logs locally in the functions console itself. But frankly, I tend to, so we can see, function execution starting, etc. I tend to prefer to see this in the Google Cloud Platform logs viewer, logs explorer, and I'll show you why. So this is giving a perfectly reasonable view of logs. But if we look in the logs explorer itself, we get more interesting things. So let's have a look at this function, this request starting. So in particular, if I switch back to the console, when I was running locally, you could see that request starting had some scopes with it. So it had a request ID, a span ID, request path, and trace ID. If I look in the logs within Cloud Platform, we'll see I've got some format parameters and a scope with 5 things in. So you've got all that information. You've got structured logging that's just ASP.NET Core normal structured logging. We're just picking up on the normal things. It's all good. So that's deploying to Cloud Platform. And if you have any questions about that, then shout. Most of the rest of the time, I will be exploring the C# specific bits. Hopefully, none of that is particularly surprising, other than maybe it being surprising that it's pretty straightforward.
John, one question here.
Yep.
So what is the tech behind logging? Is it just simple logging into DB and fetching it, or are you using some specialized mechanism like Kibana, some sort of that?
The specialized mechanism is, I'll show you the code for it, because all of this is open source, by the way. It's all on GitHub. And if I show you the hosting logging, right? So when the server starts up, it detects whether or not it's on, well, any K platform. So it looks for a K_service environment variable. If there is one, it uses JSON logging. Otherwise, it uses a simple console logger. So this is what happens when you're running locally. We just use console.writeline. If you're logging in the cloud, then we create some JSON, and that JSON knows the right format that Google Cloud Logging, previously known as Stackdriver, expects. So, for example, it converts the log level into the right severity. So if I change these are mostly info, but we've also got a debug entry, and exceptions get captured, etc., etc. Eventually, it would be nice if we have more tracing facilities as well, and that may well come with OpenTelemetry in the end. But yeah, the logging is, in both cases, it writes just straight to the console. The structured logging, when you're on Google Cloud Platform, is achieved via writing appropriate JSON.
Thank you.
Okay, cool. Was that actually what you wanted to know? I'm never sure whether I might answer a completely different question that's not what you were thinking.
You answered exactly, but I have few questions. I
Fantastic.
can wait until the end. Thanks again.
Okay, cool. Right. So we'll now switch to Visual Studio, where I can show you the Hello World function again. So this is what we had before for the Hello Chicago and the project file. And I will just explain a little bit about how it all hangs together. And it's quite handy that I've still got the source code available in another tab, because I can show you the magic of Google Cloud Functions hosting. So you can see this is just an exe. As far as the compiler is concerned, this is just a console app. Okay, but all we've got is a function. So you may be wondering, how is this actually executing? And if we go back to the Hello Chicago thing and go into the obj debug directory, Netcore app 3.1, right, now we'll see some interesting stuff. So if you've looked in your obj directory before, you'll have seen auto-generated code. So .NET, the .NET tooling generates assembly info for you automatically, but in our case, it also creates this hello chicago.program.cs. And the way this magic happens is I've got a build target, an MS build target within the NuGet package for Google Cloud Functions hosting. And one of the things that that NuGet package, NuGet target does is generate this file. And it pretty much always just looks like this file. In fact, it really is always exactly this. So this is in a global namespace. It doesn't depend in any way, shape or form on the source code that you've got, because it just passes the assembly that it's part of into the entry point class and the start async method. So this is really just bootstrapping. But the fact that you don't need a program.cs is kind of cool. I haven't yet worked out, I know there's stuff going on within the ASP.NET Core team and the C# team. I'm aware of C# code that doesn't have, I can't remember what it's called, top level methods maybe, where your program.cs is just, hey, here's the content of the main method. So it doesn't use that at all at the moment. I haven't really explored it very much because I tend to think that you probably don't need it any more lightweight than this. You don't actually get the copyright statements to start with, so you would get 19 lines of code, and of those 5 lines of comments. If you're going to do anything of any consequence whatsoever, you're going to have more code than this anyway, so I'm okay with this. It means you're in the right place to write more code in a normal way, whatever extra classes you want. So the entry point.startAsync method, if you specified which function type you want to use, it finds that. Otherwise, it looks through that assembly and looks for anything either implementing iHTTP function,
Okay,
or iCloud event function, or iCloud event function of T. String, whatever. So it looks for anything that satisfies any of those 3 interfaces and says, right, that's the function I expect it to be. And it remembers that as the function type for all of the rest of dependency injection, because the vast majority of the mechanisms within the plumbing is just ASP.NET Core plumbing. All this does is it sets up the web application to say, for every request, I need to have an iHTTP function, and I will call handle async and return the result. There are adapters to say, oh, well, if I've implemented iCloud event of T, I'll also inject a cloud event adapter that implements iHTTP function and invokes the iCloud event function. And all of this just hangs together with ASP.NET Core dependency injection. We'll see later on how that proves kind of useful. So I mentioned before that you can run this in the debugger. So if I just hit F5, we'll see it start. It doesn't start a browser or anything by default. It just starts the console, and again you would need to, you can got quit. So if I wanted to check things there, I can hit refresh and we're in the debugger, which is fine because it's just a console app as far as anything is concerned. Integration is minimal because that's the way I like it. It's nice and simple. If you wanted to do anything more fancy in terms of integration, feel free to file a feature request. But for me, this has proved perfectly enough. And then when you're done, just kill it. Okay, so that's we know how to write a single line of text to a response. I was keen on 3 principles when designing how the functions framework would work. One was it would be minimal. So if you're writing simple code, then a simple function, then your code should end up being simple as well. Secondly, it should be testable. Thirdly, it should be idiomatic, as in ASP.NET Core developers should feel comfortable in it. So let's see how we can test this hello world function. We'll go to testability, and then later on I will talk about dependency injection. So let's open our the test project first. And so we've got a project reference to our function, fine. Package references for NUnit and the test SDK, fine. That's what you might expect. There's also this testing package. So the functions framework consists of 4 packages. You have seen the templates. You have seen the hosting package. We're about to see the testing package. What you haven't actually seen, because you very rarely need to depend on it directly, is google.cloud.functions.framework, which contains just the interfaces and things. If you absolutely wanted to avoid my hosting package, you could, and you could still implement the Google Cloud Functions Framework interfaces. Frankly, most people are just going to use Google Cloud Functions hosting. It's just simple. However, we've got this testing package, which is what you use when you want to test a function. And it's primarily geared around setting up a test server. So again, because I don't like reinventing the wheel, it uses the ASP.NET Core test server, but it makes that really easy to use for functions. So here we have a function test, and it derives from function test base. So function test base of function is a class within the testing framework. You pass in, or you specify as a type argument, the function that you're using, and it makes things easier for you. It doesn't have assertions in itself because it doesn't depend on any particular framework, but it just provides easy ways that you can then integrate it with whatever you're doing. So, for example, it has a method to say execute HTTP GET request async. You see, we're not creating a function here. We're not starting a server. We're just saying, hey, I want to write a test that executes a GET request. And let's make it fail to start with. Let's go back to saying, hello, Chicago. And now if I run my test, so this is using the ASP.NET Core test server in the background, but it operates so quickly, and again, nothing to do with me, it's the ASP.NET Core team doing good stuff, that this is somewhere between a unit test and an integration test. It's nice as an integration test because it is going through the whole dependency injection stuff. It uses almost the whole of the functions framework, and definitely all of the real ASP.NET Core, but it is blazingly fast to start up. And you may be able to see, you may not, we've got expected functions framework, but was hello Chicago. And so we can fix our assertion. In fact, let's do something slightly different. We'll execute HTTP request async. So if we don't just want to do a GET request, we can pass in a request message. And yeah, I can't even remember what we need to put in here. Request URI as path, for example, and let's put method equals HTTP method.get. Oh, that needs to be a URI. Okay, so we pass in our request, and then we also pass in an action to execute. And I think there can be, yes, it can either be a synchronous or asynchronous action. We're just going to use a synchronous one here. When we've got the response, we can Sorry. Response dot content. Oh, we do want an async one instead. So we can wait for the content to come back and do the assertion, and hopefully this will pass. Oh no, we can't. Oh, your icon dot relative or absolute. There we go, and it passes. So the reason for this happening, being passed as a delegate, is so that you can do it with the live HTTP response. When you execute the request, the various things will get disposed potentially before you want to, you can actually get at things. So you've got to pass in the assertions into that method. However, the basic idea of this is about as simple, let me go back to what we were to start with. This is about as simple as a test for a function can get. You can test log entries as well. So let's add a log entry. Oh, in order to add logs, we've got to do dependency injection. Well, let me just check this function. Now let's start off dependency injection in here. So ASP.NET Core gives you some dependencies for free that you don't need to do anything special to get hold of them. And one of those is loggers. So if I do public function, logger of function logger, and then I'm just going to save that in a field. And I don't know about anyone else, I typically just use the non-generic ilogger, and we're going to say logger.log information. John was here. Okay, and that will not interfere with our test to start with. Other than we've got Hello Chicago. So our existing test is fine. Yeah, but how do we test the logs? Now, this is something that I'm surprised ASP.NET Core doesn't have built in. Request writes to log. Within the testing framework, and if I go back to the code, Google Cloud Functions testing, you'll see we've got memory logger provider and memory logger. And these are just in-memory loggers. They keep a list of log entries because that's really useful for unit testing. You may think that testing your log entries is a little over the top, and in many applications you'd be right, and in some functions you'd be right. However, in other cases, when a function just receives a cloud event and logs what it's doing and then does something else, checking that your logging is going to work, particularly for those error cases, is really important because nothing else is going to happen. You'll give a 400, or you may just swallow the event and say, okay, well, I couldn't handle it, but I'm not going to handle it if you retry it either. So I will just log a failure. You really want to be able to test that. So let me see what we get. We have get function log entries. And if I remember rightly, there are ways of getting at, if you get at your test server, function test server, I'm sure there's a way of getting, server, that's it. Get log entries. You can get log entries for a specific category. If you've got other log entries that you're interested in, I think I don't currently have a way of getting at just all the log entries, but we could add that in the future. And I will assert that there is exactly one log entry. This returns a list. It's potentially inefficient, but I don't care. It's within a test. Entry is log 0, and then I can call log level dot information, and I will assert that we got John was here entry dot message, and that is the formatted message. And this no long, oh yeah, we do actually need to invoke it. And the test server starts with an empty set of logs at the start of each test, so that's fine, but we're not failed assert dot equals. Okay, it's been a while since I've used NUnit. Boom, right, and the message isn't John was here spelt nice and properly. I've done it slightly dodgily, and now if we test this again, the test should pass. And it goes green. Okay, so just to recap, what we've seen here is you've got a test server that you can easily use. You can also create genuine unit tests. So if I create a function unit test, if you want to pass in all your own dependencies absolutely yourself, you certainly can. And as I say, I've been doing too much XUnit. So now if I want to create a new function, I can do new function. And now I need to pass in a logger. Well, I can create a new memory logger or function. I can keep that var log equals that. And so even though we're not using the test server, you can still use the logger. And then you can call function dot handle async and do all the stuff that you would need to do. Now, in order to do that, you have to pass in an HTTP context, so you can create a default HTTP context. It's a bit faffy, to be honest, but this is the kind of thing that you might want to do if your handle async method just delegates to other methods that aren't necessarily dealing directly with the HTTP request. Then this makes that nice and easy to do. I will just leave that there, but it just shows memory logger is a useful thing. And we have already seen the start of dependency injection. So where we've got this ilogger, and you note that before it was just using the default public constructor. Now ASP.NET Core dependency injection is doing all of this for us. A very early version of the functions framework, I effectively, and not very deliberately, rewrote a bunch of, wrote my own dependency injection without quite realizing that I was doing it. It was a bit of a slippery slope. And then I looked more into what ASP.NET Core gives you. It's like, this is going to make things so much easier. All I need to do is ask for a function each time and then call handle async on it. So let's look at more interesting dependencies though, because not everything is a logger. So I've got this other function called zone clock, and let me set that as the startup project and show you what that does. Obviously, it does time zone stuff because I'm me. Give me any code and I will try to work out how time zones are involved. And you can make a request and say zone equals America/Chicago. And when it's actually started up, the server hasn't started, so I would expect this request to fail to start with. Oh, it's taking a long time. Something is hitting my machine. I'm not quite sure what. There we go. Okay, it's running now. And if we say zone equals American Chicago, then it says current time in UTC, current time in America Chicago, and I can put and zone equals Europe/London. I think, yeah, that will give us all three. So 2 questions. How do you write this code and how do you test it? So I'm using the NodaTime library, obviously, as the main author of NodaTime. And in order to make things testable at all, I want to inject my clock dependency. So this doesn't use UTC.now anywhere because that would be hard to test. Instead, it uses the iClock dependency from NodaTime. So let me stop running. So if I look at my function, we'll see. So ignore everything I'm not highlighting. We'll see that we're trying to receive an iClock and the logger. And I'm just using value tuple constructor here. So how are we going to get this iClock from anywhere? This makes it nice and testable. So in my unit test, I would, in a genuine unit test, I could pass in whatever iClock I wanted. So a fake clock from nodatime.testing. And we'll see how dependency injection for test aspects works in a minute. But where is this going to get it from normally? Well, here I'm using somewhere between an Azure Functions idea and normal ASP.NET Core idea of a startup class. So the functions framework has the idea of a function startup, and you can have many of these. And idiomatically, as in the convention that I've ended up with because I've been lazy, you can decorate the function itself with an attribute to say the startup classes for this class, this function, are those startup classes. And idiomatically, you call, if you've only got one of them, you call it startup, but you can have many. That derives from function startup. And here we're overriding configure services. Now, I would hope, if I've done my job correctly, then anyone with an ASP.NET Core background would be entirely unsurprised with what I get with override. If I can do override configure, which is effectively to configure middleware. I can override app configuration if you want to get your configuration from somewhere else. So app settings works out of the box. You do get environment variables in your configuration, but you could also fetch it from another server or whatever. You can configure logging, and all of these are hopefully what you would expect to see in a function, in a startup class. In my example, I'm only overriding configure services, and that just adds a singleton of iClock for system clock.instance. So that means effectively, I said the code doesn't contain UTC.now, datetime.utc now. It effectively does because that's what system clock.instance uses under the hood. But my code doesn't need to know about that at all. It just gets an iClock, which means I can use clock.getCurrentInstant. Great. Okay, so hopefully that makes sense in terms of startup classes. As I said, you could have, if I had 2 different startup classes, you can configure multiple of them. You can even specify ordering where the order is lower to higher. So if I do order equals 10 and order equals 20, then it will execute this one first. Otherwise, it just goes in lexicographic order. It is nice and stable. It's predictable, but it's configurable as well. This also allows you to use startup classes from other assemblies. So, for example, if you are a middleware author, you could create your own NuGet package that depends on functions framework Google Cloud Functions hosting, and has your own, my fancy middleware configuration startup that derives from function startup, and then your users can just add a dependency on that NuGet package and add an attribute, and that's all they need to do. They don't need to write anything to call your code directly. It just happens automatically, which was not a designed feature. It just dropped out, and I was really pleased. I've shown you having a startup function on the function itself. You can also, and this is where the inheritance of ideas from Azure Functions makes itself a little more obvious. You can also specify it as an assembly attribute. Again, type of, and the annoying thing is that this can't be in a namespace, so you have to do zone clock dot startup. Now, it's obviously simpler to put this on the function itself. If you have a project with 10 different functions, maybe 5 of them, or maybe they all use 1 or 2 startup classes, and then each of the functions has its own one as well. Well, you can have the common ones as assemblies, assembly function startup, and then specific ones on the function itself. So hopefully that makes some sense. Again, do shout otherwise. We've got about 10 minutes. I'm going to show you dependency injection for tests, and then I will briefly describe events, but then probably call it a day at that. So there should be some time for questions. Just throwing a pen around. Okay, so we have our function test that derives from function test base. That should look very familiar. And look, we have decorated our test class with the function startup attribute. In this case, fake clock startup, which is a class down here, which again derives from function startup, and will just add a singleton using a fake clock. So I want to be able to assert that the result of a particular function execution is exactly whatever, as if I have stolen the stopwatch, stolen the clock that's being used, and I've set it as it happens to June the 3rd in 2015, which you can see actually here. So if I were using datetime.utc now, this would be really hard to test for exact output. I'd have to say, okay, well, I'll take now and maybe parse the result, check that it looks okay, etc. That would be really annoying. And we can sort of show the kind of thing that would happen if you don't have a function startup specified on your test. Then if you, let's just run our simplest test. I'm expecting to see a failure here. It's getting there. Right, so I will just copy and paste the error here, otherwise you won't be able to see it properly. So that's the error I'm getting. So by default, it's used the production function startup, which uses 2021 because it's using the system clock. We want it to be 2015. So when we do use the function startup and inject our dependencies that way, our test will pass. And then we've got other tests for other zones. We've got a test for saying, well, we asked for American Metropolis, and that's not a valid zone, but check that I've got a warning message, a warning log entry for that. So just to recap here, if you have dependencies other than a logger, then you just add your dependency package as normal. It's just a normal package reference. You configure dependency injection in exactly the same way as normal. This is a normal web host builder context. It's a normal iService collection. And you specify the function startup on the function or on the assembly. And then when you're writing tests, you can specify one on the test class itself, and that just gets automatically used. If you're doing anything really fancy, then you can all of the convenience that's provided by function test base, you can do yourself using test server builder, I think. Server equals new test server builder, function test server builder. And you can specify, maybe use function startups from attributes, or use function startups and you pass in the actual function startups themselves. There are things you can do yourself, but I'm expecting that the vast majority of people will be able to manage just with this. So to recap, I wanted something that was simple, so that a simple function would have simple code, it would be testable, and it would be idiomatic, so it would not be surprising to ASP.NET Core developers. I hope I've succeeded in those things. If I haven't, instead of being kind and saying, oh yes, I'm sure it's very good, please do shout, because I would rather improve things. Obviously, now we've hit 1.0, I can't improve things in a breaking way, but I'm sure there's plenty that I would be able to do. I'll just mention briefly cloud events. So if you haven't heard about cloud events before, they are a CNCF Cloud Native Code Foundation project to have one sort of abstraction for events. Events such as someone's created an object in a storage bucket, or a pull request has been created, or a database row has been inserted, or all kinds of things, or a pub sub message has been received. It's a very flexible specification, so there are many different representations, but they would all have a cloud event has an ID, it has a timestamp, it has a source, etc. In .NET, in the functions framework, instead of, I'll just add a new function in here rather than creating a whole new project, just because we're running out of time. But if I do a pub sub event, for example, pub sub event function, and I'm going to implement iCloud event function of pub sub event data, I want to say. I will show you where that's going to come from. I'm going to include a new package reference to google.events.protobuf. And now I should be able to do google.cloud.pubsub functions. No. Google.events. Nope, it's not liking this tool. Hang on. Okay. Google.events.protobuf.cloud.pubsub.v1.message publish data. Okay, so normally that's all you would do. It's just been a little bit of a long time since I've done this, and you would implement the function, and you basically, instead of being called with an HTTP request or context, you get the whole cloud event. You get the, I know what to expect, so I've already done the deserialization to give you the data that you want. So I could then do, if I had a logger, just for the sake of argument, let's assume we had a logger, I could do logger.log information received event with topic, and then data dot subscription rather. I think actually for the legacy event conversion, we don't populate subscription. That was possibly a bad idea. I could do message ID instead. Message ID. Okay. And if you need to do anything async, you do it at this point. Otherwise, you can just do task dot from result 0. Seem to remember, are there non-specific task dot completed task? That's what I meant. And then you deploy that, not using trigger HTTP, but using the appropriate pub sub specific way of deploying. And then when your pub sub topic receives some information, receives a message, then your handle async method would get called. So this uses the Cloud Events SDK for C#, which I'm also now maintaining, but I'm working with Microsoft on that. So that's the nice thing here. So I'm not expecting Microsoft to adopt the functions framework. However, if you write code that uses Cloud Events, then I expect that you would be able to, in the longer term, use exactly the same code with hopefully some event propagation from Google to Microsoft or Microsoft to Google. You should be able to write the same code to receive the event, whether you're running on the functions framework or on Azure Functions. Once you've got the event, then you can do things in the same way. So that's the idea of Cloud Events, this generalized abstraction. It doesn't generalize what does a pub sub message look like, it is what does the overall event look like, and if there's going to be any standardization of pub sub from Amazon, from Microsoft, from Google, that has yet to be done. Okay, so that was a brief tour. If I put the links back up, all of this, we go into a fair amount of information on that in the blog post. So if you search for tour of the functions framework or tour of the .NET functions framework, you'll probably find that anyway. I'm aware that I talk quite quickly, and we've gone through a lot of material. Hopefully you'll find that sort of fun to play with. Do sign up for a Google Cloud Platform account if you haven't already. I think you do need to put billing details in, but I'm pretty sure that functions are free for the first million invocations or something silly, and they're very, very cheap after that. Okay, thank you very much. Do you have any questions, anyone?
Yes, I do have.
Cool.
Thanks again, John. I saw your code, functions code at GitHub. So most of code looks like generated code. So is it a transpiled code? So why is
almost nothing within functionsframework.net is generated. Most of our class libraries, our API client libraries are generated, but they're not the functions framework. So if you tell me exactly what you were looking at, I can answer you a bit more.
Okay, I might have seen the libraries, the client libraries then.
Right. I'm happy to talk about those as well. So let's give an example of, so this is where the client libraries live. And if I go into API gateway, for example, then everything in here is indeed generated. So you've got a client class, and this will be thousands and thousands of lines of code. Yeah. We have very carefully written the generator so that even though this is all generated, it should feel as close to idiomatic code as you can. And obviously it means that it's consistent across APIs. All of this is generated from the API definitions, which are in this Google APIs repo. And then if we go into, I was doing API gateway, wasn't I? Let's just look for that. API gateway, we don't want the Bazel file, we want the protos. So it's all generated from these schemas. So this is just schema information. So what does an API look like? Well, it's got a name, it's got a creation time, it's got an update time, etc. And then you've got a service that defines the actual RPCs of list gateways, get gateway, etc. So that's what the API gateway service client would have. It would have various list gateways methods and get gateway methods, and all of that is generated. Yes. So I suspect that's what you were looking at.
Okay, cool, thanks. So my next question is, I mean, if someone else have a question, I can give some time before I keep on asking. So yeah, anyone else, please, if you have a question.
Looks like the floor's yours.
So my next question is, maybe I want to know some of your thoughts. How did you organize your functions code from philosophical side? That it might help us in like implementing inheritance. That might help us in, sometimes you have a certain way to put code, so that can help in debugging, in future enhancements.
So are you talking about what I would anticipate in terms of the functions code you write, or is this more general, you know, what do I look for in clean code?
Yes, what you look for in your clean code,
Okay.
specifically in your functions code, not the client library, but the code
Okay.
that runs behind the scenes.
So in the functions framework itself.
Yes.
So
exactly.
I have to admit, there isn't a huge amount of code here.
Yeah.
Most of it, it ends up being slightly tortuous because there are a bunch of extension methods. Most of it happens with extension methods, things like add functions environment. That is, I try to be idiomatic with whatever I'm doing. And in this case, I'm configuring ASP.NET Core. That's really what the hosting package is all about. And we'll see, I mentioned the entry point before. Most of the code just makes this bit work. So configure web host defaults is normal, but then add functions environment, add functions command line, add functions console logging, configure Kestrel for functions framework. These are all just extension methods. So normally I wouldn't have nearly that many extension methods. But that is the way that ASP.NET Core is designed. This is significantly out of my normal comfort zone. I don't really know that much about ASP.NET Core, so I hope I have written these appropriately. Now, most of these are currently, some of them are public. Yeah, so there are a bunch of these that are public, and you could create your own web host builder if you wanted, instead of using my entry point. I very much doubt that anyone will use most of these, or I expect very, very few people to call any of these themselves. They should work, and you know, if they don't work, then let me know and I will try to fix them. But they're normally just internal, and ultimately, most of the extension methods are relatively simple calls that then end up calling into hosting internals, which have the real guts of things. I don't think I've got any particular patterns here. There's lots of static methods in here because there's extension methods all over the place. But my normal coding style has things like design for inheritance or prohibit it. So I have more sealed classes than most other developers probably. I do try to get separation of concerns appropriately. In my experience, if you mess up the separation of concerns, you will be stuck forever and it will be hideous. And that's one of the toughest things to know until later on, is whether you've got that separation of concerns wrong. And that can be in either way. You can end up with two classes that really should be one, or one class that really should be two. And the terrible thing is, you're not going to find that out until you've got significant users, at which point you've released 1.0 anyway, so it's too late to fix it. I kind of think that all code has to hit 2.0. We had the same thing with Cloud Events. By the time I started working on the Cloud Events SDK, it was already version 1.38 point something. And I looked and thought, I really want to fix X, Y, and Z and do all these things, but I'm not going to be able to. Okay, I will propose to the other maintainers, let's do a 2.0. Let's work out everything we want to break now, because this is probably the only chance we're going to get to really fix it. And the same thing happened with Node Time. You know, Node Time 1 lasted several years and gained a certain amount of traction, but I thought, I've got just about sufficiently few users that I can do Node Time 2 and have fairly significant breaking changes. And I think I've now got to live with that forever. You know, we have released Node 3.
I think he's having some bandwidth issues. Okay.
Oh, okay, he's back.
Hey, John. So I think your last statement ran into some bandwidth issues.
Yeah, I've just now received the your internet connection is unstable. I was only waffling. It's fine. I don't think you missed anything significant. Okay, next question, Mandeep, unless anyone else has one.
So, we can keep on talking, but in the interest of time, this is my last question.
Okay.
So from how much code I have seen, looks like you haven't used any meta programming or any source generators.
Nope.
Okay. Any thoughts you want to share on that? Because I have seen there is a lot of advantage in using meta programming. You can do a lot of cool stuff to increase productivity, like you can add hooks for logging or maybe captures something which may not be possible from within the solution. If it's possible within the solution, but then you have to write that code at a ton of places.
Right.
Otherwise, if not, you can skip this question.
I haven't done any. I have looked at C# code generators, but not written my own yet. I would like to do that at some point. But yeah, my experience when I have tried using things like this in the past is they're great until they're not. And when they're not, you're in a world of pain and you don't understand what your code is doing anymore. Which the same can be said for things like async and await. Like when you get a really weird async problem, you have just no idea when your code is executing or what's going on. But the rest of the time, it's absolutely beautiful. So metaprogramming could be exactly like that. Likewise, source generation. I guess with source generation, at least you could potentially debug through the actual final source code, which is useful, or maybe invasive, depending on whether you want to be debugging in just your code or the generated code. But yeah, I certainly haven't used any in here.